Welcome back to Haskell Live Coding with your host, Mitchell Salad. That's me. So, I know that I said we're going to be moving on to step 3, which is rescoring diagonals, but I was trying to code it up just now, and before I promptly deleted everything, of course, so that I can pretend like I'm coding it for the first time in front of you all. But I realized two things. One is I forgot one step of step 2, which is to return only the significant diagonal, so I have to do some sort of filtering. And another thing I realized was I would like to change diagonal info a little bit, and instead of keeping only an index into S1, with which the index into S2 can be reconstructed, I found myself having to pass around the lengths of the initial strings, which was annoying me, so I'm just going to make this a tuple. The indexes into both S1 and S2. So let's try compiling this and deal with these compiler errors first. Okay, so I would like to clean this part up a little bit. It's not obvious what's happening. So I'm gonna start hacking away at it. So first, let's get S1 index and S2 index from X. Oh, one other thing I forgot was that last time I mentioned I was just gonna do this off camera, but then I decided that's a bad idea in case you want to follow along. So the stop index is actually index plus k minus 1 for reasons we discussed last time. Okay. So now I would like to have little helper functions. Adjust score. And this is going to be that piece of the lens composition, and then adjust start. So there are actually two starts to adjust here. There's the start of S1 and the start of S2. So let me rename this adjust start 1, and that's going to be I'm going to compose two lenses here. One of them is dstart, my automatically generated lens. And after that I have a tuple, so I want to modify the first element of a tuple with this lens from the lens library, which just affects, it's a lens on the first element of a tuple, kind of like first. And what I want to do with that is modify it by setting it to min S1 index. Let's see if that compiles. Not in scope. Right. I'm going to need second also for the second string. Where was I? Here we go. Okay. Let's adjust start 2. And finally, with those two, I can make a single function called adjust start, which just composes both of them. I realize there's a lot of lat bindings and it's super ugly looking, but it's going to look nice down here in the call to adjust with default. So I also have to address this issue, which is that the default score can be 1. The default indices are no longer just index. It's actually S1, S1 index and S2 index, which is actually just X. And then this one is going to become X plus K minus 1. Well, what it really is S1 index plus K minus 1, S2 index plus K minus 1, which is unfortunate and ugly. But the lens library comes with a couple functions, over and both, and I'm going to use both in composition. So over both elements of this tuple, I want to apply the function plus k minus 1. See if that compiles. It did compile, but it shouldn't have. Sometimes my syntactic just lies outright. It doesn't lie, it looks like there's errors, but they're not showing up in the left bar thingy. Oh. There we go. Not in scope. That's why I knew it wasn't going to compile. Both and over. And again, you can refer to the lens documentation for more information on what I just did. And now, basically, I'm going to put some comments in here. If insert, the next one is going to be adjust score and adjust start and adjust stop. And that's if adjust. And then we have the key. So let's make adjust stop. And this is going to be, this is going to be the max of S1 index plus K minus 1. I realize there's a lot of repetition in this code, but for now I'm just going to leave it how it is. Okay, let's see what that got us. So, no errors. This binding for S1 shadows the existing binding. Oh, I'm just going to call these convenience strings S1 and S2 tick. Okay, so no compiler errors. I can get rid of this. And I think I'm going to stop there because I finished what I wanted to do, which again was reworking dstart and dstop. And did I do something else? I think I did. Just kind of some refactoring. So, oh, I completely forgot. No, I'm not stopping at all. I forgot I have to get only the significant diagonals. Okay, so let's think about this. So I'm mapping to diag score over this dot plot, and then I'm just returning that outright. But I think what I want to do is I want to call that, and then I want to further modify my state. And I want to filter the diag scores so that they're above a certain threshold. And according to the PDF here, we want only the diagonals on which the score exceeds the expected score by at least 2 standard deviations. And because the standard deviations are directly tied to the K and also the size of the alphabet, I think this is safe to just hard code. I don't need to calculate it by any means. Just gonna say it's 20 for now. And so I'm going to want to filter my map. And let's pull up GCI. Okay, so it takes an A, and in our case, our K is a diagonal index, and an A is a diagonal info. And so I want to get inside the diagonal info and compare its score against the score threshold. Where am I? Here we go. So I want to first get at the, well, I'm not gonna need actually the parameter because it's just gonna reduce down. I need to get at dscore, and after that okay. Not in scope. Oh, okay. I'm sorry. This operator is like field access in an imperative language. So the lens goes on the right. So let's get it in here. It's basically just like get. Okay. And one more thing I want to do is I only want to take the top 10 significant diagonals. So I'm going to need to sort my diag score, which means I need to make it an instance of ord. And the minimum complete definition of ord is just less than or equal to. And that is because ord is a subclass of EQ. So I'm going to need to define EQ as well, or make it an instance of EQ. So here I just want to compare the scores. So I can do D1 no instance for EQ. Minimal complete definition of EQ is just equals, or not equals. And I'll just say that diagonal infos are equal when their scores are equal. Seems fair. Okay, now both of these compile. Just for fun, I want to see if the precedence is such that I can remove these. Looks like it is. Okay, why not? A do notation statement discarded. Okay, I don't care about the result of this. Basically what I want is data.traversal mapm underscore, but it doesn't exist, so just get rid of that warning. So now that I can sort these things, Let me get sort from data.list. There's also sort by, but I just made it an instance of ord because I wanted to. So this is going to be kind of messy, but after I have my filtered diagonal scores, and remember a diagonal scores is a map. Oops, where am I? So I want to list it, then sort it, then from list. And it still compiles. And then also after the sort, I want to take the top 10. And then I also think I should probably just make a little helper function, take n, which takes an int and returns, and a map. And prime so I don't get that shadowing warning, which you can disable, by the way. Compiler flag. This is going to be like that. So I can replace all of this with my call to take n of 10. And I forgot to do that. And some type constraints. Hooray, it compiles. Okay, and I still have warnings, it looks like. Where are they? Oh, I don't need void anymore. Alright, so we are done with this episode. Okay, thanks for sticking with me. Hopefully next time I'll make some more progress that is not just refactoring due to improper design. Alright, thanks a lot. Bye.